All right, now we have seen t-test, ANOVA, and its versions. So it's time to see the correlation. Correlation. Let's go ahead and create alarm markdown, and can just delete this, and we create our chunk. We can launch important library, tidyverse, and learn it. All right, we can create another for our correlation. So correlation uh, is giving us the relationship between two continuous variables. In our data here, data new, we have our variables: school name, gender, accommodation, grade, school. All these variables are independent variables, categorical variables, but you have performance and income. These variables are continuous data. So correlation checks if performance is correlated with income or vice versa. Income is correlated to performance. Let's say student performance correlated or related or depend on income of their parents or vice versa. The more income parents have, is it reflected to their student performance? All right. Okay. Here we are. We can just start with mm, correlation. Let's just check the value. Correlation value. Here we have the function is COR, just correlation. Okay. And when you open it, we need to start with our data, which is data new here. We use $sign to combine it with a column we want, which is performance. Here it opens. Click on that. Then comma. Again, our data new, combine with $sign with the variable we want, income. Okay. All right. Here. Now you can learn this code, and you get it here. It shows 0.34. Okay. We can also print its results to see clearly what is its correlation value. Here we print. All right, we get 0.34. This is between 0.2 and 0.5, and it shows that it is positive but low correlation. It means we have a positive correlation between income and performance, but that correlation is low. All right, we can also get more values or just plot a matrix, correlation matrix. Here, the same formula, correlation, and our data new, and we open square bracket, and put concatenation, which is combine C and parenthesis, then put our variable in a quotation mark. The first one is performance, and another one is income. Don't forget this quotation mark. All right, so we can run this. There we are, and we can print it. Call matrix, and here we have a matrix: performance, performance, income, performance, income. Performance and performance are positively correlated, maximum 1, and the income with income positive and the maximum correlated, and while performance and income, or income and performance, correlated on 0.34. All right, we can, so it means it is correlation between performance and income for the whole data. Whole data, I mean, like all 73 observations. All right, we can specify how many observations we want. Okay, we can use this to show. Just here, we come here and just edit here. We can, after the first square bracket, we can just put a comma and space. It means that before this comma, it was showing the rows, and after the comma, they should show the columns. All right, here we can come and just say we want a correlation on the first 10 rows or observation. Okay, 1 to 10. Okay, if you run this, let's call it maybe 1. Okay, and the 1. Okay, if you run it and print it, now we can see 35. Okay, so if we change from 10 maybe to 30, okay, and run this code and print the results, wow, we can see a medium correlation between income and performance, 0.64. It means from this student from school A here through school B, almost the school B, wow, the correlation is more positive. So mostly, if you check well, you can see student in school B have a positive correlation, which is high, like it's a medium. Between 0.5 and 0.7, it's a medium correlation. Between above 0.7, it's a high correlation, and below 0.2 is just very low correlation. So when it is negative, it's a negative correlation. Okay, all right. Now here we understand. We can also, instead of specifying a row, we can also specify the variable, independent variable we want to calculate our correlation. But before, we need to subset the data. We need to create another data frame. Let's maybe go through gender. You know, gender, we have male and female, or we can create male data. Subsetting is the function. Subset. Okay, here we are. Subset. What? We need to subset our recent data, which is data new, comma, based on gender. Which gender? Double equal, quotation mark, then let's say male. Okay. If we run it, we get another data frame here with 41 observations. It means we have removed a female student here. Here we have only male student. That is how we do subsetting. All right, now we then repeat the correlation function. We don't need this one. All right, now the data is male data. Male data. Let's call it male correlation. Okay. Yeah. Male correlation. All right, we can learn this code, have it, we can print it. Wow. So you see, correlation of male is higher than the average correlation. You remember average correlation was 0.34. Okay. Now it gives us a suspect to check the female correlation, because it can't be above this since this one is above the average. Let's check it here. Just change to female, change here to F, and change here to female, here to female, and here to female. All right. We can run this code, and print the result. Here we have, wow, you see, we got a negative correlation, and this negative correlation is low because it is between 0.2 and 0.5. What does this mean? We can just plot to visualize it. Plot which data? Let's start from male data. Male data. Combine our performance and income. Okay, and let's see. Here we got a plot. You can see. We have income on y-axis and performance on the x-axis, and the dot inside the plot are the students. All right, we can also try to plot a line so that you can see that positive or negative correlation. We use a B line function. AB line, and we got one can be independent, another can be dependent. First of all, we use another function called LM, linear model, and between income, use tilde symbol to call performance, and which data data is male data. All right, here, okay. Or Ella in the line ABB plot new has not been called yet. Okay, so it means you can't learn this code alone. You have to select both the plot and the line functions. Okay, if you learn here, now you can see the line is coming here. Okay, and you can see it's positive because it's from left to right, down, bottom to up. Okay, so AB line. AB means y is equal to a plus b x. So AB in AB line function means this a is the intercept and this b is the slope of line. All right. Okay, now we can see on female side here, female, here female. Okay, all right, female. All right, can learn both here. Wow, you can see now, you can see this line is negative, showing the correlation you have seen in female student, which was negative. We can also clarify this. Let's say can come here, mention it, color, this color, let's call red. Okay, if you learn this again, then you can clearly see the negative correlation, low negative correlation between performance and income among female students. So guys, this is how to calculate correlation in various form and visualize it on scatter plot. See you in next video.